Hello, this is meteorologist Pat Spoden with the National Weather Service in Paducah. I'm going to take a few minutes here and go through nighttime and cool season tornado statistics and climatology. Before we get into all the climatology of just the nighttime tornadoes, let's kind of look at all types of severe weather that we've had since 2006. And so this is plotted out by month, whereas each one of these is a report that has come in. The flash floods are in blue. The hail is red colors. The wind damage and or high wind gusts are in green, and the tornadoes are in purple. And what this kind of shows is the distribution that we normally get in the lower Ohio Valley throughout the year. And looking at this, you can see, like, for instance, in February, March, and April, those are the big hail months where hail is the predominant type of severe weather. And then in April, you start transitioning back into wind. And generally, wind is the main threat through the rest of the months. It is interesting, though, to look at just the tornadoes alone. And notice we have tornadoes in January, February, March. Things really pick up in April, go down a little bit in May, June, July, August, September are usually low, but then look at October. Big jump up to 29, November, and we also have had tornadoes in the month of December. Okay, now that we've taken a look at severe weather throughout the year, let's kind of break it down into just the cool season. And for our part, and for most of the studies that we do, we take on November, December, January, and February as being our cool season. Now, many studies have shown the correlation between ENSO, or the warming of the water over the certain parts of the Pacific Ocean, how that influences weather around the globe. And we're really no different here in the lower Ohio Valley. The amount of influence depend upon the general weather patterns. And of course, there's other patterns such as the North Atlantic Oscillation, the Pacific Oscillation. There's many of those across the world. And a lot of those can set up and influence our weather. So let's take a look at some data. This is a study that was completed back in 2003 and 2004, but it looked at the different tornadoes and the different seasons. So during El Nino, what typically happens with the tornadoes during the cool seasons? And here there were 12 seasons used, and you can see that most of the tornadic activity in the cool season remains closer to the Gulf Coast. There are sporadic ones here and there, but generally the pattern is over the extreme southeastern states. So what about when La Nina is the main influence? Well, in this case, notice the storm track generally probably runs from Texas up into Wisconsin, and in the warm sector would be all the way up through the Ohio Valley and even up into Michigan. You can see there's been tornadoes during the cool season well up into the upper Midwest, not just along the Gulf Coast as we saw in the El Nino, but here it spreads all the way up into the Great Lakes. What about during the neutral seasons when neither La Nina or El Nino is in command? Notice that tornadoes occur just about everywhere across the Midwest. You go way out to Nebraska and out to the East Coast, up into Michigan, Wisconsin. So it's much more spread out. There's not a definitive pattern that occurs during the neutral seasons, just that tornadoes can occur just about anywhere. Okay, when we're looking through data, especially back to 1950, there are issues with the data. We know that there's mistakes, there's things that are missing, and even to this day, there's still some issues with what we call storm data, where we go and get all this information. So what we're going to do now is kind of break it down a little bit closer to where we know we have probably a little bit better data. So we're going to look just from 1996 to 2013. And again, November through February. During that time, there's been 55 severe weather events. And they may have just been hail or may have just been a tornado, but when you put them all together, 42 of them had damaging thunderstorm wind gusts. So 76% of the severe weather events had some damaging thunderstorm winds or high wind gusts. Now, 23 of them had at least one tornado. So if there were 7 or 8 tornadoes that occurred in one night, that's considered one event. in this case. So that's 42%. That's a pretty high number. And 64%, or 35 of them, also had large hail. If we shorten the time frame down, now we're looking from just 2000 to 2013. If we look at all cool season tornadoes, there have been 88 of them. Okay, so that's November, December, January, February. If we look just between 6 p.m. and 6 a.m., there's been 55. So out of 88 total tornadoes, 63% of them occur at night. So nearly 2/3 of the tornadoes that we get in the cool season occur in the dark. One of the things that we do often is we go back and review events to see how we are doing, where we need to improve. We always want to get better. We believe that's how we best serve the people of the area. Now, there's 3 different modes generally that these storms come in the wintertime. There's supercells, which are generally the most devastating, but supercells generally are not the difficult ones to issue timely warnings for. When we have the big issues is when we have stronger storms embedded within a line or a small line of uniformly intense storms. That's where we have problems. Whenever the storms are in lines, we tend to not do as well. So we're in the process of studying this right now. We've been looking at all the cool season tornadoes in what we call QLCSs, or quasi-linear convective systems. Essentially, this means we're looking for tornadoes that forms when the storms are in lines and occur during the cool season. Okay, a recent perfect example of thunderstorms and where we have tornadoes embedded within a line was on Halloween night. We had a strong line of a few strong storms within it, bowing out down here in Mississippi County. There's tornadoes along that area. May have been one in southern Johnson County, and there was one up here in extreme southern Williamson and southern Saline. So these are the types of storms that we're studying. So again, why do we want to study this stuff? Well, not only do we know that we need to work on it and do better, but there's also a lot of facts about nighttime tornadoes. And a study done by Walker Ashley from Northern Illinois University says the highest concentration of nighttime killer tornadoes have been in the deep south, which includes much of our region right here. And here it shows the percentage of nighttime tornadoes in each state. And this is for, I believe, all year. And the states colored in dark blue and dark blue show the highest percentage. So this shows that from 1985 to 2007, more than 60% of nighttime tornado fatalities occurred in mobile homes. This tends to coincide with the fact that the southeast United States has the highest percentage of mobile homes compared with any other region generally east of the Continental Divide. You take a real close look at the study from the work done at NIU, you can kind of determine what we determine to be a nocturnal tornado alley. And basically what it means is we can expect tornadoes during the night in our area, especially in the winter. Okay, the geographic area that the National Weather Service office in Paducah serves includes 58 counties in 4 states, including southeast Missouri, western Kentucky, southern Illinois, southwest Indiana. If we look at data from 1996 through 2012, there's been a total of 52 deaths within the area. 37 of these deaths occurred in mobile homes, basically over 70%. 11 people have died in permanent homes and 4 were in vehicles. If you look at the deaths by months, it may be surprising that some of our most active tornado months, especially April and May, contain the least amount of tornado deaths. Most of them occur during what some people would consider the off season, but hopefully by the time you're done listening to this presentation, you realize that there is no off season in the lower Ohio Valley. Tornadoes can occur any time of the year. There's many potential reasons why there's more deaths in the wintertime. Number one, speed of the storms. There's a lot more wind. The storms are moving much faster than they would in April and May, which means there's less time for people to react. They often happen at night, so people can't visually see the tornado coming. It lends itself to more of our Doppler radar indicated type tornadoes, which sometimes can be less believable because we know that there's a lot of those out there. More people are sleeping and not watching TV or watching the weather, period. They're going to bed thinking that they're safe. So one of the things we've realized is that we need to do a better job when there's potential of tornadoes prior to the 10 p.m. news. And also sometimes you have to be careful because what you read on the web is not always the best information. You know, people joke about, well, whatever's on the internet's true. The same thing goes with weather. Depending upon where you're getting your weather information, it may or may not mislead you. Another thing that happens in the wintertime around here is we can get tornadoes without there even being any thunder or lightning. And that's kind of a lot of people's, alarm clock, whereas if I hear thunder in the wintertime, I'm thinking, ooh, that's a pretty good storm. But if there's no thunder, it can still produce a tornado. Okay, so this slide has a lot of information on it. Let's try and dissect it. Okay, we're looking from 1996 to 2012, and if we looked at all the killer tornadoes, on the left side are nighttime tornadoes and the average speeds that we had with them. The one iffy one is, March 11th, 2006, 16 miles an hour. That seems a little low compared to everything else that we see. So the average of nighttime tornadoes any time of the year is 48 miles an hour. Okay. If we look at those that occurred during the day for the same time period, the average is 33 miles an hour. So that could be another thing to help to determine why more people are perishing at night in the tornadoes. If we look just at the cool season killer tornadoes, we have February 29, 2012. We have November 27th, 2005, and November 5th and 6th, 2005, and also on the 15th of 2005. You just take those, the average speed is 54 miles per hour. There's a big difference between 33 and 54. We're going to try and demonstrate that a little bit in the slides coming up. Okay, let's try to break down what speed actually is in terms that many people can think about. If you're driving down the interstate, it's 65 to 70 miles an hour. That's how fast some of these cool season tornadoes are moving. Okay, so the speed of a cat, almost 30 miles an hour. A gray fox, 42. A horse can go almost 55 miles per hour. Generally, a passenger train goes anywhere from 60 to 80 miles per hour. Most humans, you can run at 5 to 8 miles per hour and possibly sprint for a short distance of maybe 12 to 15 miles per hour. So hopefully this is kind of giving you an idea of how fast these things are moving and why you have so little time to take your plan of action. Okay, so the speed of a storm. Let's say the storm is moving at a springtime speed of, say, 25 miles an hour. This is an image of the velocity data from the Evansville tornado. So if it was just moving at 25 miles per hour for the south side of Evansville at this point, the lead time would be close to 25 minutes. So a tornado warning is issued, it's moving this fast. It would have taken almost 25 minutes for it to get to the south side of Evansville. So if we take the same storm and say it's moving at a speed of 50 miles per hour, the actual lead time for the south side of Evansville would only be about 10 minutes. So just by increasing the speed, you've reduced the time that you have to react from 25 minutes down to 10 minutes, and that's a big difference. So in the wintertime, in the cool season, you have to react quickly when tornado warnings are issued. Remember, they're hard to see. We don't get often a lot of reports until there's damage. So you need to react to these. It's very important. Okay, before we go any further, it's important to talk about what lead time is. It's kind of a strange concept, and it's essentially different for each person. Some people feel the lead time is, from when the warning is issued till the first hear thunder. Other people may say the first time they notice that it starts raining, or maybe the wind is blowing or hail is falling, or is it when damage begins? Officially, we go with the time of arrival of the event, hail, tornado, wind damage. The key point to this is there's less time to act in the wintertime because the storms are moving faster. Okay, just as a review, I'm going to go back to our cool season nighttime tornado statistics that since 2000, from November to February, we've had nearly 2/3 of our tornadoes occur at night. So let's shorten the time a little bit. And now if we just look since 2006, so the last 7 years or so, we've had 13 total tornado events. And again, that's, you could have 2 or 3 tornadoes or 1 tornado, or it's kind of like an event day. Out of that time, we've had 63 total tornadoes, and 48 of them have occurred between 6 p.m. and 6 a.m. So that's more than 3/4 of our tornadoes that occur during the cool season occur at night. Okay, so what are some of the things you can take away from this? One, nighttime tornadoes are fairly common, especially during the winter. Incredible speeds automatically give you less time to react. And the number of tornadoes that we have is closely related to the ENSO, which is the warming or cooling of the waters over the Central Pacific. Thank you for your time.